Hi all, welcome back to Malware Analysis. I am Jay Lavanya, Assistant Professor of CS Department. So in this video, we are going to discuss on the topic Windows API libraries and packing and encryption under the malware. Okay, so let's dive into the topic. So first of all, what is meant by Windows API libraries? So malware heavily relies on these kind of Win32 API functions for packing, unpacking, and encrypting the data. Some of the important categories are memory management API, process and thread API, cryptography API, and file IO API. So let's see one by one. So first of all, what is meant by memory management API? It is used for unpacking the payloads into the memory, and that is virtual allocation. Allocate the memory often that is used for some decrypted code. And next, like virtual protect, that is to change the memory protection. Example, like makes the memory executable, and write process memory, which writes the bytes into some another processes, and read process memory, which read from another processes. So malware use is that which unpacked shell code is written into memory and it will be executed. And next topic, like process and thread API, that is used for running and decrypted payload. So create the process AW, which starts the new processes, and create the remote process via the injection, which injects into some another program. And next, in this process and thread API, the create thread or the create a remote thread which execute the malicious code inside some current or some remote processes, and also like suspend thread or the resume thread which manipulate or legitimate the processes for injection. Okay, and malware use like injects into a trusted process like explorer.exe to hide the execution. Okay, and next if you take like a cryptography API, this cryptography API from advanced 32.dl, that is dynamic link library, older version. Now encrypt 32.dll, sometimes also custom algorithms also use this cryptography API. Like if you take crypt acquire context, crypt encrypt or crypt decrypt, okay, and crypt import key, crypt gen random, okay, so all those stuffs comes there. And next, in the case of malware use, encrypts its payload and communication via C2C traffic, right? We have already discussed that. And file IO API to load or pack payloads or drop the encrypted files, or create a file AW, read file, a write file, okay, get the file size and set the file pointer. Okay, for all such cases it is used. And the malware uses that read the encrypted sections from its own file, and you have to decrypt it at the runtime. So that is the main things of this you know Windows API library. Okay, and apart from that, we have like these kind of Windows API libraries relies on some kind of some special functions that is related, right? So that is, so there will be some key Windows API libraries and frameworks. As we have discussed, like Win32 API, this is a functional API for some native C or C++ Windows applications, offering some direct access to the system hardware and core Windows functionalities. It provides a vast communication of functions for managing the processes, files, memory, networking, user interface, and much more. And next, like Windows Runtime API. So that is WinRT API. It's designed for modern Windows applications, particularly UWP apps. WinRT that offers a language independent object-oriented approach to accessing some Windows features. It is built on the component object model, that is COM, and it provides access to to a wide range of services, including UI elements, file handling, and networking. Okay. And next, like Windows Apps SDK. So this SDK that provides decoupled set of Windows API, allowing the developers to build some Windows applications that are not tied to some specific OS versions. It includes both WinRT, its runtime library, and Win32 API, and it's delivered as a new Get package offering greater flexibility and independent updates. And next, like .NET Framework and .NET. So these are cross-platforms, open source developer platforms that support building various types of applications, including Windows desktop apps. While they offer a high-level managed code environment, they can also, interact with some unmanaged or Windows API through the mechanisms like platform invoke, PL invoke, when direct access is required. Okay, so these all comes under the cases where it is commonly used, and this Win32 program has some shared library also. Okay, and the next topic we are going to discuss is about patching. So what is meant by packing? So it is generally used for encrypting or compressing an executable, then wrapping it with a small stub loader. When run, the stub allocates the memory, that is virtual allocation, and second, it decrypts or unpacks the real payload into the memory, and third one transfers the execution to the unpacked payload. Okay, like common packers, if you consider for this packing, like UPX, that is a open source, and Themida or ASP pack, and custom packers. Okay, and what are the indicators of packed malware? It has some very few inputs like just load library and get proc address in high entropy sections, compressed or encrypted data, and unusual entry point code like stub instead of normal main. Okay, so all those stuffs comes under this packing concept. Okay, and here in this diagram, see what are the malware obfuscation process. So that will be like a malware code should be injected, and like stealth malware, packing, encryption, obfuscation. So these are the steps to be followed in a malware obfuscation process. Okay. So, what are the encryption techniques? But before going to this encryption, we will see some of the packing techniques. Okay, so packing involves compressing or authenticating the original malware executable. So this makes difficult for any antivirus software and security analysts to understand the malware's true nature. When the packed malware is executed, it unpacks itself in memory, revealing the original malicious code. So Windows API libraries provide several functions that are instrumental in this process. So packing, it is a technique that's used to compress and obfuscate some malware code, and the original malicious code or the payload, is compressed and often encrypted. The malware then consists of a small piece of code called a packer or a stub, whose only job is to decompress and decrypt the payload at runtime. So this makes the static analysis of the file on disk very difficult, as security software will see only the packer, which may not be malicious in itself. Okay, and malware authors leverage some several Windows API for this process, like virtual allocation or the virtual allocation executable. So these functions are used to allocate a new section of memory that is not visible in the original file's memory layout. So this new memory region is where the compressed and encrypted payload is unpacked. Okay, and next, write process memory. So once the new memory is allocated, this API is used to write the original malicious code into it. So this is a common step in memory injection and process that is following some techniques. Okay, and next, like what virtual protect. After the payload is unpacked and returned to memory, the malware needs to be able to execute it. This is where virtual protect comes in. It's used to change the memory permissions of the newly allocated region from read or write to read or write or execute that allows the CPU to execute the malicious code. And next, like create process or create remote thread. To execute the unpacked code, the malware might create a new process in a suspended state, is create process or inject a new thread into an existing or trusted processes that create remote thread. The entry point of this new process or thread is then redirected to the unpacked payloads code in memory. And next, like memory allocation and management. So malware often uses memory allocation function to create space in memory where the unpacked code will reside. Okay, like example, like virtual allocation. So this function reserves or commits or changes the state of a region or pages in the virtual address space of the calling process. So malware uses the virtual allocation to allocate the memory region with some specific permissions. Example, page execute or read and write to store some unpacked code. Like, for example, LP void p is equal to virtual allocation of will passing some arguments like null, comma size, comma memory commit, comma page execute read and write. Okay, if the variable equal to null in the sense you have to handle those errors, right? Or else a virtual protect if you're going like after unpacking the code, so the malware may use virtual protect to change the memory protection attributes of the allocated region. For example, it might initially allocate memory with page read write permissions and then change to page execute read after unpacking to prevent some modification. Okay, and the word that is old protect. So here, if the virtual protect of like say p we are passing like size page execute read when old protect that is equal to 0, then you have to handle the error. Okay, and next technique is that data compression. So data compression reduces the size of the malware, which makes it easier for transmit, right? And also store Windows API provides functions for data compressions that malware can utilize. An RTL compressed buffer and RTL decompressed buffer. So these functions are part of the Windows native API and are used for compression and decompression. So malware can use RTL compressed buffer to compress its code and data, and RTL decompressed buffer to decompress it during the runtime. Okay, and C++ is compression. U-long compressed size, that's the RTL compressed buffer, which passes some compression format like LZNT1 or uncompressed buffer argument and uncompressed size argument. Okay, so all those stuffs comes under this compression. And next, like a U-long final size, here also in RTL compression buffer, they used to pass decompressed size, compressed buzzer, compressed size, and final size. Okay, so these are the compression techniques where it will be used in the packing. And next, like loading and relocation. So after unpacking, the malware needs to load and relocate its code correctly, right? So if you are loading the memory and get the proc address, while primarily which is used for loading DLL, malware can use these functions to load the parts of itself as if they were separate libraries. Okay, so get proc address can then be used to uptime the addresses of specific functions within the unpacked code. Okay, like in C++, if you're writing like h module, like module variable equal to load library, you're loading the library. Say for example, like unpacked code DLL file you're just loading, and if that particular h module is not equal to null, then you have to go for some for practice for fragmented, like get proc the address and pass the module, command the function name which you want to go for the loading and relocation. Okay, and if that particular key function is not equal to null, We have to call the function again, like p function of, and then we have to free of the library that is passed in the hash module. Okay, so these are the loading as well as relocation concept. And next topic is that code injection. So packing is often combined with some code injection techniques where the unpacked code is injected into another process. So here you have to create the process, write the process memory, create the remote thread. So these functions are commonly used for code injection. So malware can create a new process, write the unpacked code into the process memory, and then it can create a thread to execute the injected code. Okay, so here also, okay, so here also we have to create a new process, like create process function. We have to pass the arguments like null, comma target process.exe file, and some special pointers, and then we have to write the unpacked code into the process memory. So for write process memory, we have like pi.h process, comma address, unpack the code, comma size, comma null. So these are the arguments which you have to pass, and we have to create a remote thread to execute the injected code, like create remote thread of pi.hash process command null comma 0 comma lp thread underscore start underscore routine address, right? So these all comes under the packing techniques. So next topic is that encryption techniques. So here this encryption is used to protect some sensitive data, right, and code within the malware so that it makes it difficult for the analyst to understand the malware's functionality without decrypting it first. So malware uses encryption for protecting the code, so analysts can't easily see the logic. And second point, like protecting the configuration files or the strings, like C2 servers or the API keys and much more. Okay. And third, like protecting the communication, like TLS, RC4 or AES, right? So all those stuffs comes under this particular thing. Okay. And the typical flow is that the encrypted payload stored in data or the resource section it at runtime. So malware calls the crypt decrypt or the custom XOR loop. So decrypted code copied into some virtual memory. So execution jumps into the decrypted region. So malware uses these encryption to hide its payload and network communication. So this prevents the static analysis tools from finding some malicious strings and makes it difficult for some security systems to understand the data being sent to command and control server. The Windows cryptography API is a prime target for the misuse. Okay, and crypt acquire context, before any cryptographic operation that can be performed. A handle to a cryptographic service provider must be acquired. So this is done using crypt acquired context, and the CSP provides the actual encryption algorithms and the key storage. Okay, and second one, like crypt gen key. So this function is used to generate a new cryptographic key. For example, a ransomware strain might use a crypt-gen key to create a strong AES key to encrypt a victim's files. Okay, and third, like crypt encrypt or crypt decrypt. So these are the core functions for encrypting and decrypting the data. So malware uses these crypt encrypt to encrypt its C2 traffic or a victim's files and uses some crypt decrypt to decrypt the commands received from a C2 server. And next, like crypt derived key, rather than generating a random key, some malware might derive a key from a password or a hard-coded value using this function. So this provides a way for the malware to use a predetermined key without it being stored in a plain text. Okay. And next, we will discuss some of the encryption techniques which is used. So the first of all, these are the encryption techniques used in packing, like Windows Crypto API, like crypt32.dll file. For advanced encryption standard, we can go for some AES, that is thing, and custom encryption algorithms also we'll be using. So now let us see one by one. So first of all, Windows Crypto API, right? So this crypto API provides a set of functions for performing cryptographic operations like crypt acquire context that acquires a handle to cryptographic service provider, that is CSP. And second, like crypt create hash that creates a hash object. And third thing, like crypt hash data, which adds the data to the hash object. And fourth one, like crypt derive key. It derives a cryptographic key from a base data value. And next, like crypt encrypt and crypt decrypt encrypts and decrypts the data, some using a specified algorithm. Like in a C++, if you're going there, they will be using like Hatch Crypto Pro, like Hatch Pro, and Hatch Crypt Key, Hatch Key, Hatch Crypt Hash, there is Hatch Hash. And for acquiring some cryptographic context, you need to use this function, crypt acquire context. Just now I told, right? So there we have to pass the arguments like ampersand H pro, that what are the variables we have declared, and null ms enhance pro and pro comma rsa full. And next you have to create a hash object. So crypto creates a hash pro calg md5 and comma 0 and ampersand hash. So crypt, and then for hashing the password also we need some crypted hash data, that is hash comma byte stub this password and string length of the password comma 0. And then you have to derive a key from the hashing, crypt derived key like hash pro comma calg underscore rc4 and hash comma 0 comma ampersand hash. And next, like encrypting the data, crypt encrypt, that is hash key comma 0 comma 2 comma 0 comma data comma ampersand data length comma data length. And for decrypting the data, crypt decrypt, that is hash key comma 0 comma 2 comma 0 comma data comma ampersand data length. And next, for releasing the resources, crypt release context. Here you have to pass the hash pro comma 0 and crypt destroy key also, hash key you have to pass out. Okay. And next, advanced encryption standard, that is AES. So AES, yeah, if you have studied the cryptography, right, network security subject in business, you will be master in this topic. So here, AES is synthetic block cipher that is widely used for encryption, and malware can implement AES using the Windows Crypto API or by including a custom AES implementation. So bcrypt open algorithm provider or decrypt generate symmetric key, bcrypt encrypt, bcrypt decrypt. So these are the functions that are part of the CNG, that is cryptography next generation API, and it provides a more modern interface for cryptographic operations including AES. Okay, and in C++ like bcrypt underscore algorithm underscore handle algorithm and bcrypt underscore key underscore handle hash key and end status and status. You have to open the AES algorithm provider, like bcrypt open algorithm provider. Okay, so you have to pass the algorithm, bcrypt AES algorithm, what type of algorithm you are passing, and command al comma 0. Then you have to generate a symmetric key. For that generating a symmetric key, you have to pass the algorithm ampersand hash key comma null comma 0 comma key size, and then we have to encrypt the data. So status is equal to decrypt encrypt hash key data comma data size comma null comma iv size comma encrypted data size and ampersand of data size comma 0. Okay. And next, for decrypting the data also, decrypt, that we have to pass the arguments like hash key comma encrypted data comma encrypted data size comma null iv size comma decrypted data size comma ampersand data size comma 0. Okay, so these we have to pass for decrypting the data, and once we have done, we have to close the header. Like Bcrypt close algorithm provided that is H algorithm, comma 0, and bcrypt destroy key. So here we have to pass the H key. Okay, and next one, custom encryption algorithms. So here some malware authors implement their own encryption algorithm to avoid some deduction by signature-based antivirus software. So these algorithms are often simpler than the standard encryption algorithms, but can still be effective at obfuscating the malware's code and data. Okay, and next, like key storage, and see there is one more technique. There, malware needs to store and exchange the encryption key securely. So it may use some techniques such as hard-coded keys, key derivation, and key exchange protocols. So what is meant by hard-coded keys? It's storing the encryption key directly in the malware code that is least secure. And in key derivation, deriving the key from a password or other input using a key derivation function, that is KDF. And next one, key exchange protocol, that is implementing key exchange protocol like the Hellman, yeah, to secure the exchange key with the a remote server. Okay, and apart from that, in so here these are the encryption techniques, but why does malware use these techniques, right? Evasion, bypassing signature-based detection or obfuscating behavior. Okay, and also like randomization. Okay, so what are the challenges if you take like static analysis failure? So traditional static analysis, which examines the code before execution, so is ineffective against packed malware because the actual malicious code will be hidden. And next, like dynamic analysis required to analyze the packed malware, the security analyst must resort to some dynamic analysis. So this involves executing the malware in a controlled environment like a virtual machine to observe its behavior as the unpacking routine runs. And next, like computational cost. So dynamic analysis, which can involve using some universal unpackers, that is computational expensive, but it requires actually running the malware. Okay, and so how it works is that in packing encryption, first of all, there should be a packing, followed by the step or the wrapper, and then the execution and unpacking, and then malicious. So once a payload is unpacked in memory, the step transfers control to the original entry point of the unpacked malware, allowing it to carry out some malicious functions. Okay, so these all comes under the, uh, packing encryption, these encryption techniques, right? And I would like to say there are other. mm, So before I'm going to conclude, I'll just say some unpacking techniques like dynamic analysis, memory dumping, emulation, automated unpackers, anti-analysis techniques, debugger deduction, sandbox evasion, virtual machine deduction, countermeasures like security experts employ a variety of cutting-edge tools and strategies to successfully battle on malware packing and anti-analysis measure. And second, like behavioral analysis also, here monitoring the malware activity in a controlled environment, if you take at least to detect some suspicious actions and generate the indications of, you know, compromise in the IOC. So this aids in learning how to manage business in the real world circumstances. And static analysis, hybrid machine learning environment. So in essence, I would just want to conclude by saying that even though there are so many Windows 32 libraries like encryption or packing tools, an essential part of malware which will be seen like their obfuscation also. So that anti-analysis techniques are unpacking and unpacking, packing process. So by comprehending these kind of methodologies is vital for some cybersecurity experts to proficiently assess and reduce the malware risk. So security specialists can remain ahead of the malware game by utilizing a combination of advanced tools and approaches with some static, dynamic, and hybrid analysis techniques. Okay, so So in packing, I have seen what is my packing and what are the techniques involved is and how it is coded in the programming and what kind of encryption techniques it's used in malware, right? And apart from that, there also we have discussed like Windows Triple API, advanced encryption standards, and custom encryption algorithms, right? I hope this video will be very useful for you. We will see you in the next video. So thank you all.